Hello, hello, LinkedIn family. Welcome, welcome, welcome again to everyone to what I'm hoping is a pretty fun demo day session. We're going to start off with what is a deceptively simple question. How do you connect securely to your account? To help me with this topic, I've got Jose Palafox, Director Technology Partnerships for GitHub Advanced Security, as well as a special guest, Luke Walker, Director of Developer Programs at Yubico. Jose?
Thanks, AJ. As AJ mentioned, I'm Jose Palafox, and I work on our technology partnerships team covering our security products. Today, what we want to talk with you about is, how can GitHub help you secure your GitHub account and the projects that you work on? We've known for a long time that passwords are not a sufficient security mechanism for protecting sensitive information. People tend to reuse passwords. People can have their credentials purchased online, and people can use that to stuff into multiple account services to try to compromise an account. They're subject to brute force accounts where people will just try to guess your password, or people can try to phish you for your password. So there's lots of ways to get around passwords by themselves. And at GitHub, we really want to fix this problem. And most attempts at fixing it are kind of poor. What will happen is, a systems person will implement, say, a complexity requirement on the passwords, or will force password rotation after some period of time. And these ways of trying to make passwords more secure tend to just incentivize the user to go around them. You end up using the same password everywhere, or incrementally changing one capital letter, or writing your passwords down because they're too complicated to remember. And that sort of defeats the whole purpose of trying to improve password security. And we feel like for developers, we've just got to have a better answer. So we've been partnering with Yubico for some time, probably since 2015 or 2012, maybe. It's been a very long partnership with Yubico to help improve account security using YubiKeys. And so today what we want to show you is how you can use a YubiKey to set up SSH access to your GitHub account and store the credential on the key. Before we get to that, I want to spend just one more minute on some of the steps that we've taken to help you secure your account here at GitHub. Since 2013, you've had the ability to use SMS-based two-factor authentication, as well as time-based challenges to better protect your account. In 2018, we started blocking the use of known bad passwords, tapping the Have I Been Pwned data set to identify already leaked credentials and prevent you from using a password that has already been compromised. And then in 2019, we started introducing verified devices, which require that you verify when you're logging in from a new device. We also monitor on the back end if you're logging in from geographically impossible locations, or logging in from a new geography that you haven't used before, and we'll notify you that there's been a login attempt on your account. In recent years, what we've been doing is dropping support for passwords altogether. On the API, you can no longer authenticate to GitHub using a password. You have to use a personal access token or some kind of API credential to authenticate. And recently, we extended that to SSH. So you can't SSH to GitHub and execute Git CLI operations without using a token. And this isn't done just to, help you be more secure. It's a deliberate attempt to secure the internet, because GitHub has so much open source technology on it that underpins sort of everything we do in modern life. And so we think it's really important that users secure their account. And I think YubiKeys are a great way to secure your account really simply. As Luke will walk you through, all you'll have to do is touch your YubiKey by the time we're done with this configuration, and you'll be able to access your GitHub account. So Luke, you want to talk a little bit about Yubico and our demo here today?
Yes. Thanks, Jose. Yeah, Yubico has been really proud to partner with GitHub over the years to continually improve account security. As you mentioned, we kind of started with FIDO U2F, which has then progressed into the WebAuthn specification, and allowing you to secure your account with a security key, and the benefits that WebAuthn and FIDO2 offer. And now that can be extended to your SSH Git operation. So your one security key can like protect your account and your software supply chain. And so yeah, let's go into what I'm going to talk about today. So I kind of want to give you a brief peek into how like security keys for SSH work behind the scenes under the covers, and then we'll do a quick demo. So here's a quick overview of the FIDO2 protocol. So what are the advantages of FIDO2? As Jose mentioned, passwords can be weak. That's how most data breaches occur. And so what FIDO2 brings is strong hardware-based authentication using public key cryptography. It can protect against phishing, session hijacking, man-in-the-middle, and malware attacks. There's no secrets shared between services. The private key is stored securely on the device's secure element. With FIDO2, it gives you the opportunity to use the user verification feature. This could be a PIN, something you know, or it could be a biometric, something you are. Privacy was built into the protocol from the beginning. Users can choose their own identity online. They can have multiple identities with one key, including anonymous. There doesn't need to be any personal information associated with it. And every time you sign up or register this security key, it's generating a new public key for every service. It's scalable. FIDO2 in combination with the WebAuthn spec just works out of the box with leading browsers and devices that we use every single day. And for application development, you just need to add in some simple API calls through the browser or a native SDK library to quickly integrate strong authentication into your products or services. And it improves usability. I feel using hardware-based keys is fast and easy. It enables various authentication experiences. You can have your second factor experience where your username, password, plus a physical device, a security key. It also allows multi-factor authentication from the key itself. So it'll have, you possess the private key, and with that user verification feature, there's the something you know or something you are. And then there's an option called password, I like to call passwordless authentication. That's where you don't even need to type a username. You can do everything from the key itself. So let's look at the FIDO2 ceremonies really quick. I'm going to quickly cover two ceremonies. There's the registration ceremony, and in our case, the SSH keygen command. This is when we're registering a new credential on the security key, and then next we'll go into the SSH or authentication ceremony. So when we look at this command, you specify the options, the type of key you want to generate, and maybe some options. The SSH client's going to create some client data. It's going to send that to the security key. The security key will generate a private public key pair. It'll use that private key to sign over the client data and that public key, send that back to the client. The client can then verify the signature using the public key, make sure nothing was tampered with and everything's good to go. And then it'll produce the private and public keys that we're used to seeing every day and when we use SSH. And what's interesting to note here is that this private key is not really where your private bits lie. This is actually a reference to the security key. So if your private key is taken from the machine, it's useless without having the security key along with it. And then if we look at the authentication ceremony, it's where we want to SSH. The client's going to package up some client data. It's going to send it to the key. The key is going to retrieve the associated private key. It's going to sign over that data after you provide user presence or user verification. User presence would be like touching the key. User verification would be the PIN or biometric. It's going to send that data back to the server, where the server can verify the signature using the public key, and that the client data hasn't been tampered with, and that if user verification was supposed to be performed, that it was everything on the ceremony happened as expected. So let's quick jump into the demo. All right. In this demo, we're going to generate an SSH key pair, set up GitHub access, do some get operations, and then we'll go into some advanced topics like resident keys and pins. All right. So here I've got my terminal, I've got my YubiKey plugged in. I'll run SSH keygen. And the first thing you need to know is what kind of key type you want to create. So you'll notice that we've got two that begin with -SK. We've got this ECDSA and this ED25519. Both of them have the -SK at the end. That stands for security key. So these are the two types of SSH keys you can create. Now, if you older YubiKeys are going to work. All YubiKeys are going to work with this first version. The 25519, you'll need a newer YubiKey circa 2020 or so to be able to take advantage of that key type. All right, so now let's generate our key pair. We'll specify the type, ECDSA -SK, and we'll just call this SKey. All right, now you see it's saying I need to touch my authenticator. So here I'm providing user presence and touching my key. I'm going to skip the passphrase. And if we look, I've now got my private key and public key. So as I mentioned, this private key isn't actually the actual private key. It's actually like a reference to my security key. And so all the sensitive information is stored on the security key itself. And so if you're the only person that has physical access to the security key, then it's safe to leave it plugged in at all times. All right, the next step is we want to set up our access to GitHub. So I'm going to copy this test key to my SSH directory. And then I can show you, since I'm going to be connecting to GitHub, I'm just going to set up my config file to automatically use the test key when I log into GitHub or try to connect to GitHub. Okay, so you can see when I try to connect to host, github.com, I want to use my test key. So this is what I've got configured. All right, so then I'm going to take the public key and copy it up to my GitHub account. So here's my SSH keys. I want to add a new one, call it my test key. Copy and paste the public key in there. Whoop. It's going to want to ask me to use my security key to confirm access. All right, and there we are. Now we've got everything configured. Now we can get to the main event, which is to test that this actually works, and we can secure our SSH with hardware-backed security key. So I've got an example repository here. It's private, so it's going to require access to interact with it. So let me make sure I've got my SSH here. I'm going to get the URL. here we go. It's prompting me to touch my YubiKey. So I'll confirm presence. That's how easy it is. I know it's not super exciting, but there we go. I've got access to my my repo. Now I can show real quick what it looks like to make a change. So we'll just create a new file. And commit it. All right, so here you can see it's prompting me for a PIN. I've set up signature, get signature verification with my account. So that's all this is. And then I'll type hit push. It's going to prompt me for my SSH to touch my SSH security key again. And we're in. So if we go back to and refresh my repo, we should see there's our test file. There you go. Now that's how easy it is to protect SSH access with a hardware-backed security key. All right, now just touch on some advanced topics such as, oh, got a little feedback here. Resident keys and pins. So let's say you're an administrator and you want to be able to walk up to any workstation and plug in your security key and quickly and easily set up SSH access securely. Then I think resident keys are a great option for you. What is a resident key? You specify at the option resident when you create the credential. And what this does is it stores a little bit of information on the key itself that allows you to generate the public and private keys on demand. You just run the SSH keygen -K, and that'll produce a couple of your public and private key files in the current directory, and then you can use them like you normally would. So now it's important to note that anyone who has possession of that security key has access to your resources, right? When they have the resident key, right? So they have the key. You can plug it into a machine, and generate the public key and the private key that refers to it. So, what if your key is stolen? How do you protect that? Well, that's where we touched on earlier, that FIDO2 user verification. That's where that comes into play. So you can set set a PIN or use a biometric and enforce that on every time you want to use the key by passing in the option verify required. So if you create a key with these two options, you're going to be able to plug it in on any computer, generate your public and private keys on demand, and protect access with a PIN or a biometric. Security key. Oh, I moved ahead too far. What happens if you lose security key? Then you won't be able to perform your GET operations, or SSH operations. So make sure you don't lose it. And I always encourage everyone to create a backup key and keep it in a safe place. And so you just repeat the steps that we followed to do that. So yeah, in summary, I think it's been great partnering with GitHub and bringing modern security to the GitHub community. We talked about the advantages of FIDO2, how it works, the protocol works under the covers, and how easy it is to secure your SSH GET operations. So I think we got some there. I think there's some questions building up.
So one question that came in, Luke, was can I hardware back a signed push event? And I think if you jump us forward in a slide here, we'll have an answer for that one. So if you're looking for more things you can do with your security keys, like backing a single push event, you can check out our white paper on commit signing. That will actually walk you through that process. We wanted to kind of keep this user flow today really simple, but definitely signing commits is sort of the next 201 topic here. You can scan that QR code to check that out. Also, if you need a YubiKey or are interested in setting one up, you can get one from the GitHub shop. You want to grab another question here? We've got a pretty big backlog.
Sure. Let's look through this.
I think one I saw come in earlier is why are tokens more secure than passwords? And I think a lot of that just relies on having it be machine generated and having sort of the operational tools available to rotate keys and manage them a little bit better. Also, when they're machine generated, you can use patterns or use other techniques to identify that it's a security key. And if it gets leaked, products like GitHub's secret scanning can identify it really quickly and let you know that you've accidentally made public something that should have been kept private. But Luke, do you have any other thoughts on why using keys is better than using passwords?
Yeah, I think you hit all the major points at the beginning of the presentation. They can be phished. Complexities around it, can make it difficult for or easier for attackers to find this shared secret, right? Where security keys use public key cryptography in the background, so there's no secret being shared, and that's I think that's the primary reason we call that strong authentication.
Another question that is coming in is like, what's next after we start securing keys? And I think if you could bump us forward 2 slides, I can talk a little bit about that really quickly. So if you're looking for more security options on GitHub, we do have a whole set of features focused on security. If you're familiar with Dependabot, this is a tool that lets you know if you're using insecure dependencies in your software code. We also have GitHub code scanning, which scans or performs a static analysis scan on your software and will let you know if you've introduced known bad coding patterns into your software and catch it before you publish it. So kind of on your Git pull, you can run the security tool and analyze the source code for any known bad patterns that map to an OWASP or OpenCVE or something of that sort. And those alerts will come in as PR comments for you so that you can resolve them. So if you're looking for kind of what's next in your software development security, YubiKeys are a great first step, kind of getting the front door really secured, and then afterwards, some of our other security features can really help you out. Just going through some of these questions here to see what else we want to jump on. One is, as an administrator, can I require users to use security keys? I believe you have an option to require multi-factor authentication inside of your GitHub admin controls. So you can require that your accounts or user accounts have multi-factor set up. I don't think that it requires a specific flavor of multi-factor. I'd have to dig into the specific options there, but I think if a user sets up like a time-based access using an app or something like that, that would also satisfy that requirement. But you may have other organizational controls to tell people what kind of two-factor authentication to use. Luke, you seeing any other questions you want to grab here?
I think you can see all the questions. I don't think I can see them.
Oh, I'm sorry. I'm scrolling through. There was quite a bit of chatter here, so really appreciate the involvement here. If people have questions, feel free to shoot them in. I'm seeing them as quick as I can. One other thing we can tell you about, if you want to step back a slide, Luke, is if you'd like to see a longer version of this presentation, both setting up the SSH keys and then also setting up commit verification, which we talked briefly about. You can go ahead and scan the QR code there on the screen, and it'll take you to YouTube video that we shot to kind of do more of a step-by-step config. And Luke's able to go into a lot more of the detailed configuration options than we did today. So if you want to set up resident keys or some of the other features he talked about, you can follow along on that video as well as the documentation. There are a couple more questions in here that I don't have really great answers for. Let's see, is there a way to enable MFA for code push and pull outside of trusted networks? I'm not sure what this one's asking, but I will circle back and figure out. I think what we're showing should work over the internet, so it's outside of a trusted network for sure, and it can be used to connect to your GitHub.com account from anywhere. All right, well, thanks again for attending today and for learning a little bit about security keys. I think this is a thing that I'm really passionate about. If you have 10 minutes, please go set up two-factor on your GitHub account. It's one of the easiest things you can do to make sure that you don't have your account ever compromised. And I think as Luke showed you, generating the token and getting it onto your key is really just a couple of CLI commands. And once it's set up, all you have to do to access GitHub is just touch the key. So you don't have to memorize passwords anymore, and you don't have to really think about your account security nearly as much as you did before with passwords. So this is kind of a one and done sort of solution that gets you kind of instant access to your GitHub account.
Awesome. Thanks so much, Jose and Luke, for joining us today. I think you've laid out some really practical steps. I know that most folks have been living in a password world for so long that it seems like maybe we've gotten passwords figured out. The truth is, it hasn't been figured out. It's been figured out by introducing some different flows to things. So hopefully folks will enable two-factor authentication and keep securing their accounts. Awesome. So to close out, I'd also like to give a quick plug to GitHub Universe. If you like this subject as well as a lot more fun stuff that we're going to be revealing during Universe, we've got a 2-day event coming up at the end of October. It's actually pretty brief, only 2 hours of live programming per day, but there are also a lot of options. So if you do see something that's exciting on the schedule, go ahead and go to githubuniverse.com to keep updated. And it should be a really, really super fun event. With that, thanks again, everyone, for joining us on Demo Days. Thanks again to Yubico and Luke for joining us and helping us out. Thanks to Jose. And thanks, as always, to my behind-the-scenes partner in crime, Liz Corsi, who is an amazing person. And thank you so much for putting all this together. And thank you again to everyone watching for another awesome episode of Demo Days.